locked here for a second. Let me go on this. We did addition had an opposite. It was subtraction. Multiplication has an opposite. It's called division. And what we're going to do here is we're going to look at how division can happen. Alright, so if I have a collection of things, so I have a collection of things. I've gathered something together. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37. I have a collection of 37 things. But I want to give 5 of those things to people. I want to put it in bundles of 5. Maybe it fits in the box in bundles of 5, right? And so I grab 5 things, and I grab 5 things, and I grab 5 things, and I grab 5 things. Grab, wait a minute. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah, that's good. And I grab 5 things. 4, 5. And I grab 5 things. I'll grab these 5. Did I miss one? 1, 2. Yeah, that one should have grabbed that one. I knew there was something wrong there. And so I've created containers that have 5. Well, I notice that there's 2 things that aren't in my containers. But I have these containers of 5. In fact, how many do I have? 1, 2, 3, 4, 5, 6, 7. And so division is dividing up the stuff we have. And so in this case, I did 37 divided by 5. And my answer was I had 7 things with 2 left over. And with whole numbers, when we're dealing with whole numbers, we have no idea of fractions or decimals yet. What is left over matters. And for me, a good way of visualizing what we're doing here is think about I have a box that it only holds 5 things in it. And I've got 37 things. I start filling up boxes. And I find out I fill up 7 boxes. But I still have 2 things left over that won't fill up a box. And that's what remainders are for. And so it's an important way to look at how division will work, or what division means as it comes across. So we're going to look at our algorithm that we need to make this type of division work, or how we can have division come back and forth on us. All right, let's go here. I am still not seeing chat stream here, and I'm trying to fix that so you hear me pause underneath it all. All right, no one's talking. Yeah, that's why. Sorry, I'll just keep this window open so that I can see that also. I just have to make it quiet there. There we go. All right, so we want to find an algorithm for this. Now, what we're going to find is that division, and I'm going to write it in the way you might be used to seeing it. We have a divisor out here, something that divides the inner number. A dividend, which is the thing that's being divided, and the quotient, which is the answer, plus the remainder. These things get these weird names. I'm not big on naming things. This book is, and it walks it through. And I think at least getting a feel for the name helps with the communication. but I am extremely, extremely into what the things mean. And you'll see when we do fractions, I'll even call the upstairs and the downstairs of the fraction will be the things to work by. So what your book says is, hey, you know what? This all works together, that the quotient times the divisor, whatever that multiplication is, plus the remainder, equals the dividend. And then your book's going to talk about it that way. And so we kind of want to have that language for this to work. Well, the emphasis of everything today has been on using place value to help us do that. So I'm going to show you the algorithm for doing divisions using place value. It requires that you memorize multiplications in reverse. And I'll show you how. So let's try to get my examples up here. 2 seconds as I load my examples. My notes crashed on this one computer, so I'm just going to pull up the notes since I put them online. It's not the example I want. 2 seconds here. I opened the door and looked in the closet, but I had already set it down behind me. All my notes came out of the book, so I'm just pulling back to the book. Where are my division problems? Here we go. Yeah. Move some things around here. Good. All right. So I'll start with our divisor is just going to be a single digit. And for some reason, my single digits today are 6. But I wanted to divide a large number so we can look at this. It'll be 29,427. So what we'll do is we'll look at place values one by one. I'm going to write in zeros right now. We normally don't write in those zeros that are to the left of our numbers. And so I take my divisor and I look at the first place value. And I go, how many times does 6 go into 2? Well, it goes 0 times. And so I put that up above. And I multiply 6 times 0. And I get 0. And I subtract 0 from 2. And I get 2. And I'll bring down the next place. Now I'm going to over here redo this step the way most people do this step. I want my pattern to be consistent, and I'll continue the pattern down here, but I want to re-show this step. Most people, if the first number is 0, they then continue and go, how many times does 6 go into 29? And it goes 4 times. Then they multiply 4 times 6, and they get 24. And then they subtract from there. And they bring down the next digit. This is how, if you ask me a question, I'll do most examples. I don't write my zeros up above until I get to the first thing that can divide into it. But the pattern is we look at each digit and we go, how many times does it go in? It goes in 0 times. 0 times 6 is 0. Subtract, bring down the next place. Now this is the new number I'm looking at. How many times does 6 go into 29? It goes in 4 times. 4 times 6 is 24. 24 taken away from 29 is 5. Bring down the next digit. And notice we're in the same place now. Each time we get a new answer, we go, how many times does 6 go into 54? Well, it goes in 9 times. 9 times 6 is 54. 54 take away 54 is 0. Bring down the 2. I'll do it over here again. Sorry about the repeat here. I just wanted to show you how these algorithms people do differently. 6 goes into 54 9 times. 9 times 6 is 54. Subtract, bring down the 2. And so this is the new thing we're looking at. Notice how we're repeating and there's a cyclic motion in here. And I'll write down the cycle when we're done. I just want to look at the cycle here. 6 goes into 2 0 times. 0 times 6 is 0. Subtract, bring down the next digit. And I'm going to repeat that over here. So 0, 0, 2, bring down. This is the new thing we're looking at. How many times does 6 go into 27? It goes 4 times. 6 times 4 is 24. Subtract 3. I have nothing to bring down. And that's my remainder. Let me put 4 here. And I usually use just like an R period to represent the remainder. So we've taken a pattern with our place values in a division. And we were working our way across. Now notice, in multiplying, we worked our way through place values from right to left. Division, we go left to right. And so the algorithm that we can take from this is that we use a box with the dividend in the box. And the divisor outside of the box. All right, I'll scroll back up. There's our dividend. There's our divisor. Working left. Told you you'd hear thunder eventually. Left to right. Find how many times the dividend goes into the place value. Write the answer above the place value. I'm going to do a quick scroll up here. All right, we figured out how many times 6 went into 2. We wrote that above. Multiply this answer by the divisor and write the result below the dividend. All right, so up here I took the 0 times the 6 and I wrote the answer below the dividend. Subtract the result from the place value of the dividend. Yeah, I'm going to move my desk around. My hand is cramping on this thing. So it happens when I've been using a blackboard for the first half of the summer, you know, writing big, large strokes, and now I'm writing on like something the size of a half sheet of paper. It's a little more cramped. I will do better. Subtract the result from the place value of the dividend bring down the next place value on the right. These little algorithms can be wordy. Okay. So I subtracted 0 from 2. There was my answer. And I bring down the next place value. Repeat using this new number. Until you have no place values on the right. And so we kept repeating. I repeated using the 29. It goes in 4 times. 4 times 6 is 24. I subtracted, brought down. And so there's little repetitions. So this is a multi-step thing that gets repeated and repeated and repeated until I run out of place values. Again, the emphasis in mathematics is looking for patterns in things. You will find a lot of the techniques we do are patterns, and sometimes patterns repeat. And so repetition happens in this, and so we can crystallize this into 6. I've seen this as 6 or 7 steps. So let's do another one here. Go into the book here. I'll do one with a bigger number. So I have 38,095 divided by 42. Now here, this is bigger than a 1, right? Or bigger than the ones place. It has something in the ones place and the tens place. That's all right. I can do the whole thing. Let me just make. Yeah, my 8 doesn't look sickly there. Well, okay, it looks sickly, but not as sickly as I had it before. 42. So I'm going to skip writing the zeros above. You can write the zeros above if it helps. So 42 cannot go into 3, right? It's too big. 42 can't go into 38. It's too big. But 42 can go into 380, right? In fact, it goes 9 times. Hope it goes 9 times. Ooh, I might be able to double check myself here. So 9. So I write how many times 42 goes into 380, because that's the number of places I did. I do it in the place value above. And my next step is to multiply. So I multiply this times 42. 9 times 2 is 8. Carry my 1. 9 times 4 is 36 plus the 1 is 37. So I'm going to keep jumping back and forth to the instructions here. All right. So working left to right, find how many times the dividend goes into the place value. Write the answer above. Multiply and write it below. Those I did. Now I'm going to subtract and then bring down the next place. So I'm going to subtract 8 from 0. Well, I can't do 8 from 0, so I'm going to borrow 1 from here. So 8 from 10 is 2. 7 minus 7 is 0. And 3 minus 3 is 0. So I got 2. Bring down the next place value. Well, that is my new number. And I now repeat. Well, how many times does 42 go into 29? 0. Once I've written my first number, I have to write my zeros. They matter. And 0 times 42 is 0. 29 minus 0 is 29. Bring down my 5. Now, how many times does 42 go into 295? Well, 7 times 4 is 28. So it's going to be either 7 or 6, depending on if it's too big. So I'm going to try 7 and see what happens. 7 times 2 is 4. Carry my 1. 7 times 4 is 28, plus 1 is 29. Subtract. I have nothing more to pull down, so I have a remainder of 1. Long division isn't taught as much as it was, again, because of the proliferation of calculators. It's really important in algebra that we have a sense of this repetition cycle. You really should practice the long divisions that the textbook have. In fact, in the textbook, the physical copy on page 53, there's a set of mixed practices. You should be comfortable doing those by hand.